Hello everyone, welcome to Mathematics Pathshala. This is Norris. Today I will discuss this problem which came in CSIR UGC net December 2023 in part C. This question from complex analysis. Let's see the question. For an integer k, consider the contour integral ik equal to this, then we have to find which of the following statements are true. Before doing this problem, we will recall the residue theorem. What is residue theorem? Let's see. Let f be an analytic function on a simple closed contour C except for isolated singularities inside C. Then the contour integral over C fz dz becomes 2 pi I into summation over residues of the function f inside C. Okay, here what is given that here ik equal to integration over mod z equal to 1 e to the power z by z to the power k dz. So here fz equal to what? Fz equal to e to the power z by z to the power k. Now you can see that when k less than equal to 0, you can see the function e to the power z by z to the power k has no singularity. When k less than equal to 0, when k less than equal to 0, the function e to the power z by z to the power k has no singularity. Therefore the function fz is analytic when k less than equal to 0. So when k less than equal to 0, the function fz equal to e to the power z by z to the power k is analytic on and inside the given contour mod z equal to 1. Okay, so by the Cauchy's theorem, what we can say that? We can say that integration over mod z equal to 1 fz dz will be 0 since fz is analytic on and inside the contour mod z equal to 1. So the by Cauchy theorem what we get, the integration becomes 0, that is ik, so ik becomes 0, ik becomes 0 when k less than equal to 0. So ik becomes 0 when k less than equal to 0. Now when k greater than equal to 0, when k greater than 0, that means k greater than equal to 1. When k greater than equal to 1, the integrand fz equal to e to the power z by z to the power k has a pole at z equal to 0 of order k when k greater than equal to 1. So the residue of fz at z equal to 0 will becomes at when k greater than equal to 1, residue of fz at z equal to 0 will becomes 1 by k minus 1 factorial limit z tends to 0, k minus 1 times derivative with respect to z into z minus 0 to the power k into fz. So from this what we get, 1 by k minus 1 factorial limit z tends to 0 dk minus 1 by dz to the power k minus 1 z to the power k. Fz is what? E to the power z by z to the power k. This zk cross off. So what we know that e to the derivative of e to the power z is e to the power z with respect to z. It will be e to the power z. So after k minus 1 time derivative, it will gives e to the power z. So basically we get 1 by k minus 1 factorial limit z tends to 0 e to the power z. So at z equal to 0, e to the power z is 1. So basically we get 1 by k minus 1 factorial. So residue of fz at z equal to 0 is 1 by k minus 1 factorial. So the So the integration will becomes 2 pi I into residue. Residue is what? Here 1 minus 1 by k minus 1 factorial. So basically we get 2 pi I by k minus 1 factorial. That is ik. So ik equal to becomes, so ik becomes ik equal to 2 pi I by k minus 1 factorial for k greater than equal to 1. So basically what we get? We get ik equal to 2 pi I by k minus 1 factorial for k greater than equal to 1 and 0 for k less than equal to 0. Okay, so now you can see that in option 1 what is said that ik equal to 0 for every integer k. You can see that for k greater than equal to 1, ik is 2 pi I by k minus 1 factorial, 2 pi I by k minus 1 factorial, that is non-zero. So for k greater than equal to 1, ik is non-zero. So option 1 should be false. In option 2 what is said that ik not equal to 0 for k greater than 1, k greater than equal to 1. What we get? We get this one for k greater than equal to 1, ik not equal to 0. So option 2 should be true. In third option what is said that mod ik less than equal to mod ik plus 1 for every integer k, Okay, so when for k greater than equal to 1, for k greater than equal to 1, mod ik is what? Mod ik is 2 pi by k minus 1 factorial, and mod ik plus 1 is what? 2 pi by k factorial. Now what we know that k minus 1 factorial is less than k factorial. So from this what we can write? 1 by k minus 1 factorial is greater than 1 by k factorial. From this we can write 2 pi by k minus 1 factorial is greater than 2 pi by k factorial. That is what? That is mod ik, and that is mod ik plus 1. So basically we get mod ik greater than mod ik plus 1. So mod ik is greater than for mod ik plus 1, but in option 3 what is said that mod ik is less than equal to mod ik plus 1 for every integer k. We get opposite one. For k greater than equal to 1, we get mod ik is greater than mod ik plus 1 for k greater than equal to 1. So we get that opposite one. Therefore option 3 should be false. Now what is said that limit k tends to infinity, mod ik equal to infinity. Let's check. As limit k tends to infinity, mod ik equal to limit k tends to infinity 2 pi by k minus 1 factorial. Now as k tends to infinity, k minus 1 factorial will be going to infinity. So 2 pi by infinity becomes 0. Therefore it becomes 0. But it is said that infinity. So option 4 should be false. So here only option 2 is right option. Other option are false. Thank you for watching this video. Thank you very much.